Right. This is the last of the conic sections. There's more in this chapter. We're just cutting it. I'm not going to do the second part of it. Specifically, there's a couple of people today, when I was going around, you're showing me sketches of parabolas, and they weren't vertical or horizontal. They were like tilted. Right? If you keep going, you figure out how you can actually do the ones that are tilted. It's not what you would think. Right? In fact, what you do, if you want to graph a, since I'm being recorded here, if you want to have a graph for, let's say, an ellipse which is tilted like that, what you actually do is you tilt the x and y axis, right, so that they are going like this. There's your new x-axis, and there's your new y-axis. And with respect to those axes, it is vertical now. And that's how you come up with the equation of a tilted, not strictly horizontal or vertical. But we're not going to do that part of it. So first we're going to do hyperbolas. And I think I'm missing one bullet on there. And then we're just going to figure out, I mean, based on, we have the four conic sections in front of us. If you get the general form of a quadratic, can you tell which one it is? Without doing anything to it at all, can you just tell which one it is? For example, which is the only one of the four that only has one squared term? Parabola, right? So if you see that, you say parabola. That's all you have to do, right? So we'll figure the rest of it we'll do by the end of the one today. There's no real work to do it. You just recognize it by the pattern of this squared terms. That's the whole thing. Now the hyperbola actually has two parts to it. Okay, it has a definition which is really close to that of the ellipse. If you remember, ellipse was, the definition was the set of all points, the sum of whose distances from two fixed points is constant. The hyperbola is the set of all points, the sum, the difference of whose distances from two fixed points is constant. So it's not a sum, it's a difference. And that difference, because we take absolute value of that distance, it actually leads to two different pieces of a hyperbola. Right? Each one of these is called a branch. Right? That's one branch, and that's the other branch. Now, the two fixed points are still called foci. One focus, two foci. Now, you can look at each one of those branches like it looks like a parabola. It kind of looks like a parabola. It's not a parabola, right? If you overlaid a parabola on that, they would not line up completely, but they kind of look like parabolas, right? Each branch, right, parabola-looking thing, has a vertex exactly where you would think it would be, right? There's a vertex, there's a vertex. The center is halfway in between the two vertices. This time we don't call it a major axis, it's called a transverse axis. Okay, now notice the relationship now between A and C. A still represents the distance from the center to the vertices, right? So here's A. But the foci is sitting inside the branch over here. The C still represents the distance from the center to the foci, or to each focus. So which is going to be bigger for a hyperbola? The C will always be bigger than A. That's exactly reversed from what we had with an ellipse. For an ellipse, A was always the biggest. For hyperbola, C is always the biggest, because the vertex and the focus have kind of switched relative positions here. Good. Stop. Now, when you look at the standard equations, they should look pretty familiar. Okay, here's the two standard equations for a hyperbola. Compare those with the two standard equations for an ellipse. What's the difference? There's a subtract in between the terms instead of an add, right? Which is, kind of expected when you go back to the definition. We said it was the difference of whose distances from two fixed points. For an ellipse, it was the sum of whose distances from two fixed points. So it makes sense. Okay, the transverse axis, right, was the thing that's defining whether it's horizontal or vertical. So we have two of them, right? We have a horizontal and we have a vertical, right? What's the difference in the equations between those two? Well, remember, what was the difference between the two for an ellipse? What changed? The A's and the B's switched places, right? But now look at these. The A's and the B's are in the same place. They don't switch. Okay, they don't switch. What switches? The X minus H and the Y minus K. So what you notice is when it's horizontal, the first term, which is the positive term, is the X term. When it's vertical, the first term, which is the positive term, is the Y term. So whichever is the first, X or Y, is going to determine whether this is horizontal or vertical. And of course, they always give us these, this is what it would look like if the center was at the origin, right? Then the H and the K are 0, so everything simplifies quite a bit. Now, we know what A is. We know what C is. We don't know what the B is yet. We're going to get to that. You have to see it to understand what B is, okay? But what we do know is that we have a Pythagorean theorem kind of relationship between A, B, and C. And in this case, it's the C that's always guaranteed to be the biggest. So it is actually exactly like the Pythagorean theorem. C squared equals A squared plus B squared. Good, Jonathan. So when you look at the pictures, right, this is a picture of the horizontal, this is a picture of the vertical. And notice the equations again. The vertical, it's the Y term is first. The horizontal, it's the X term that's first. The A's and the B's are in the same place every time. Remember what we knew about A and B in an ellipse was A is always bigger than B, right? A had to be bigger than B. We don't have the same kind of relationship in a hyperbola. A can be bigger than B, A could be less than B, A could even be equal to B. They could have the same denominators. No problem with that. Okay. 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 So in order to understand what the B is, I'm going to show you how you sketch one of these. And then you understand through the sketching of this where it comes from. What is the center of this hyperbola? -1, +2, right? So the center is still HK is -1, 2. -1, +2. Is this thing horizontal or vertical transverse axis? Horizontal because, right, this is transverse axis horizontal. Because the x term is first, and the x is the horizontal coordinate, right? Tells you how much to go left and right. So that, what is the value of a? What is the value of a squared? A squared is 16, right? So a equals 4. Right? That tells us in a horizontal direction, we're going to go 4 to the left and 4 to the right. Right? Those are going to be the vertices. Okay, what is the value of b squared? Right? B squared equals 9. So b equals 3. All right. This is what you do with b. Okay. You're going to go in the other direction, up 3 and down 3 from the center. You go up 3 and down 3. Okay. Now, with these 4 points, you're going to draw a box. Right? I'm going to do this by using a line here. Line. Come on, don't mess me up here. So we're going to draw a red line and make it a little bit fatter. Dashed. Right. So now we're going to draw a box that has those 4 points as the midpoints of each side. Right. So that's what the B is telling us. You know, it's helping us to draw the box. Okay, next. Not sure I wanted that in that color, but that's okay. Next, you draw the diagonals of the box. Okay, let me draw a different color here. Would be well, just a blue. Draw in the diagonals of the box. Right. Those diagonals are going to be asymptotes for each branch of the parabola. Let me go back to this. Back to that. Let me make that a fat line. So we know that these are the vertices, right? These are not vertices, right? In the perpendicular direction, that distance b is telling you where to draw the box, but they're actually not part of the hyperbola. Okay, now here's the vertex for this branch. You're going to draw each branch using those dashed lines, the diagonals of the box, as asymptotes. We know what asymptotes are, right? The graph approaches but doesn't touch. Same thing on the other side. So again, the reason that we do this now is so we can explain what the B is. Right? That was the B. That was the A. Now, the one thing I didn't do is I didn't calculate the C. How am I going to calculate the C in this case? No. That's if it's ellipse, right? C squared equals A squared plus B squared. Right? So C squared in this one is 16 plus 9. C squared equals 25, so C equals 5. So if we want to know where the foci are, we expect them to be inside each branch, right? 1, 2, 3, 4, 5. There's one focus. 1, 2, 3, 4, 5. There's the other focus. And so besides kind of showing everything there is to know about a hyperbola right there, it explains the B. Because there's no other way to really explain what the B does for you except show it, right? The B helps you draw your box. You can draw the diagonals, so the diagonals can become the asymptotes, and you use those as guides to your graph. Semplice, right? Sorry, simple. So your homework is going to be the same kind of thing we did with ellipses, right? The first problems are saying, write the equation if you know a couple characteristics, right? So the first kind of problem is given vertices and foci. And what do you think I'm going to do first? Sketch a graph. Just try to get an idea of what it is I'm looking at here, right? 4 plus or minus 4, 0, plus or minus 6, 0. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the vertices are at 4, 0 and negative 4, 0. Right? So we know that our branches are doing something like this. Right? This way, we're not being asked to sketch the graph, so I'm not worrying about drawing the asymptotes or anything. So the foci are at 6 and negative 6. Okay, so is this horizontal or vertical? Clearly it's horizontal, so we need this form, x minus h squared over a squared minus y minus k squared over b squared equals 1. What is the center? The center is right here, 0, 0, right? So the hk is 0, 0. What does this distance represent? That's the A, right? The distance from the center to the vertex is always A, so A is 4. What does this distance represent? That's the C. The distance from the center to the focus is C. So in this case, C is 6. Now, in our standard form of equation, we need H, K, A, and B. We still need the B. How are we going to find the B? C squared equals A squared plus B squared, right? So C squared equals A squared plus B squared. C squared will be 36. A squared will be 16 plus B squared. So B squared equals 20. Okay, and we don't actually need B, right? All we need is B squared. So we can fill in everything now. X squared over 16 minus, that was wrong, y squared over 20 equals 1. So like we did with the ellipse, I think the first problem was centered at the origin. So you'll have one that's centered at the origin. Here's a couple characteristics. It will lead to being centered at the origin. Okay, this one will not. Okay, so vertices at 2, 3, and 2, negative 3. Which means it'll look something like that. So vertical or horizontal? Vertical. So now I need the one which is starting with the y term. Okay. The foci are at 2, 6, and 2, negative 6. Yeah, it doesn't really, I don't need to show both of them. I know that this is the A, right? And this is the B. Oh, that's wrong, isn't it? No, that's correct. What is the center? Center is halfway in between these two, which would put it right there. right? So 2, 0 is the center. And we know what the A is, and we just have to find the B. And how we're going to find the B? We're going to do C squared 36 equals A squared 9 plus B squared. So 27 equals B squared. And now just fill in everything that we've got, right? That'll be y minus k, well, it's y minus 0. So that's y squared over the A was 9 minus x minus 2 squared over the B squared, which we said was 27, equals 1. Again, you know, we've seen already that I think the last two that we did, the B is bigger than the A. Right? If with an ellipse, that's not it. By definition, A is always bigger. Okay. Ariel, Kayla, you okay? Jonathan? Okay, the next set of problems is going to say, find the center, vertices, foci. Don't worry about the equations of the asymptotes. You're going to have to draw the asymptotes to sketch the graph, but don't worry about the equations of it. And then sketch it. Okay, so let's see. What is the center? Here's your equation. It's the origin, right? So the center is HK is right there. Is this thing vertical or horizontal? X is first, so, and first means it's positive. Don't switch them around, right? Don't make the negative term first. It's got to be the first term is the positive term. So we know that it's horizontal. So that's telling you to go how far to the left and right to find the vertices? 6, right? The A, this is the A squared, so A is 6. So from the center, it's going to go 6 to the left, 6 to the right. There's your vertices. Don't sketch them in yet because we need to do it properly. Okay, what is the value of B? B squared is 4, so B is 2. And while we're at it, let's just do the C while we're doing it, right? 36 equals, that was wrong. I started doing the wrong one. C squared equals 36 plus 4. So C squared equals 40. That makes C, you know, it's halfway between 36 and 49. It's probably around 4.4, let's say. And you could put it in the calculator to get more accurate. We just need to like place it on the graph in the appropriate. What's that? Yeah, 6.4. Thanks. Okay. Okay, so let's see. We need to go left 6, right 6. We got that. But now we need to go up 2 and down 2. Right? Then we're going to sketch our box. Let me see. I'm going to make that a blue box. I like that better. Here's our box. To there. To there. To here. And here. And then we will switch that to red. And now we draw in our diagonals. Kind of like that to be a fatter line than that. And then we go back to the pen and we sketch in the graph. Oh, I made a mistake there, didn't I? Watch this. I missed that one completely. No, don't do that. Probably not going to be able to get that. I misdrew the line there. It should have been, where's my line? Blue line. It should have been here. Right. Which changes, I think I can get it there. There we go. I was going to say, I was looking at that going, hey, we're not even going through the center of our box. That's not good. That's good. That is not good. There. And now fix that. That's about right. Blue, fat line, go from the vertex to the diagonal because those are the asymptotes. Come on. So center, vertices, foci. Oh, we didn't put the foci on there. Remember we said we should go 6.4 to the left and to the right. So that was the 6. It's just a little bit inside. There's one focus. There's another focus, 6.4. Now again, usually you would say the foci are at plus or minus 6.40, or the square root of 40, whatever. Right, which leads us to, okay, what was the difference between that one and this one? Okay, that was at the origin. This one's not at the origin. Okay, what's the center? -3, 2, right? -3, +2. Is it vertical or horizontal? Horizontal because x is first, right? So that's telling us to go how far to the left and to the right. 12 to the left, 12 to the right. Okay, so the next, going from -3, 12 to the left should be -15. Right, 12 to the right will be 9. About right there. Right, so is this vertical or horizontal? Oh, we already said that. It's horizontal. So now we're going to go up 5 and down 5. 2, 3, 4, 5. Done 2, 3, 4, 5. Right, we're going to use that to draw a box. Hopefully better this time. That's good. Hopefully I didn't mess it up this time. Then we're going to draw in our diagonals. Then we're going to sketch the graph. Right, from the vertex towards the asymptotes. Right, it should be kind of rounded, but it comes out looking more like a point. That's okay. And the foci, right? In order to do that part, we need to calculate the C. right? We know that the c squared equals 144 plus 25. C squared equals 169. So C equals 13. So this, we went 12 to the left and 12 to the right. The foci are like one inside of that, one on the other side of that. Foci. You know, and at this point that was negative 15, so we just say negative 16, 2, 9, 10, 2. There we go. Right, which leads us to, what if it's not in the standard form? Then what do you have to do? Complete the square. Then we have to complete the square. So this one, we only have to complete the square once, right? Because there's a y to the first term, but there's not an x to the first term. So actually the x's we don't have to complete the square on. So let's just do this. In one step, x squared minus 9 times y squared minus 4y equals 72. What number do I add in there? Plus 4, right? But if I plus 4 here, what do I add to the other side? Okay, that's actually negative 9 times 4, negative 36, so I got to subtract 36. Right, so this is x squared minus 9 times y minus 2 squared equals 36. Okay, not quite in standard form. Divide by 36, right? Divide 36, divide 36, divide 36. So x squared over 36 minus y minus 2 squared over 4, right? 9 into 36, 4 times. Right, so what is the center? 0, 2. What is A? Is it horizontal or vertical? It's another horizontal because the first term is x. So A is 6. So we're going to go 6 to the right. 1, 2, 3, 4, 5, 6. 6 to the left. 1, 2, 3, 4, 5, 6. We're going to go 2 up, 2 down. We're going to draw our box. So you can get colored pencils and do all this. Have so much fun. Drawing your diagonals. And then sketch your graph. Blue. And the last thing, foci, right? The c squared in this case equals 36 plus 4. You know, you keep reusing these same numbers over and over again. So c is about 6.4. So again, we would go inside there. That was already at 6, so it's just barely inside of that. So the foci are at plus or minus the square root of 40, comma 2. Okay, that's the end of hyperbolas. Now, the last thing we do is just to identify a conic section from its general equation, meaning from where you've got the x term and the y term squared, and then the x term and the y term to the first, and then the constant. Remember, the only thing that it depends on are those two terms, right? Nothing of this makes any difference at all, right? And in fact, the only thing that matters is the A and the C. Now, the way that they've stated it here, if this helps you out, by all means do it. I don't think of it like that. I mean, I would be going through these equations, and the first thing I'm looking for, which is the one that only has one squared term? Parabola. So this first one here, right, 4x squared, but there's not a y squared. That's why it's a parabola. Now, it's true, because there's no y squared terms, that means the c is 0. So a times z is 0. That's what this one is saying right there. But just think of it. There's only one of the four that only has one squared term, right? The next one, which is the only one of the four that the squared terms are opposite sign? Hint, we just did it. Hyperbola, right? The circles and the ellipses are the same sign. So if you see a positive x squared and a negative y squared, it's got to be hyperbola. Now, again, that means that a and c have opposite signs, so when you multiply them, it's less than 0. But just look for the pattern of the terms. If they're opposite signs, then it's a hyperbola. Oops, wrong direction. Now, when it comes to the other two, right, circles and ellipses will both have x squared terms and y squared terms. They will both have the same sign, right? They're either both positive or they're both negative. The difference between a circle and an ellipse is, for a circle, the coefficients are equal, right? Remember, for a circle, there are no coefficients. It's x minus h squared plus y minus k squared equals r squared, right? If there's any numbers left involved, it's got to be divided out, so it's the r squared. So it's okay to have a start of 2 and 2. In the end, you'll divide by 2, and they won't have coefficients. This is what it looks like if it's an ellipse, right? They're both squared, they're both positive, but they're not equal, 2 and 4. So for a circle, A equals C. For an ellipse, A times C is greater than 0, meaning they're either both positive or they're both negative. But you have to say A does not equal C, because that same thing could be said for a circle. So let's say, looking at these four problems right here, which is, I think there's one of each, which is the parabola? Which one only has one squared term, right? This is the one that has one squared term, so that's a parabola. Which is the hyperbola? The squared terms are opposite signs. Right there, right? So that is hyperbola. So the other two are circles and ellipses, right? Which one is the circle because the coefficients are equal? Circle. And which one must be an ellipse because they're not equal? Ellipse. Done. That's all you have to do. You're not being asked to graph or do anything at all. I know you don't like to read directions, but don't start going down the path of everything we did on the other problems. All you're being asked to do is identify the conic section. That's what we did. We're going to have a quiz now. I want to write that. I'll probably write that on the board anyways, but you need to take out some paper.